Fairly simple. Mr. Haywood's pushing a cat off a table because the cat, I don't know, ate your marking or something. And I was like, how dare you? My cat is really fat. It's a 7.5 kilogram cat. My cat actually isn't that heavy. It's like 4 kilos. And it was sleeping on your marking after it had just eaten it. So we know a resultant force, we can express it as R is equal to the mass of the object times the acceleration of the object. Newton's second law. Is there any forces pushing back? Air resistance, friction. We'll assume that's 0. So sub in the values, rearrange, and the cat accelerates at 2.67 meters per second squared. Yep, so if we don't integrate, we can just use this handy physics formula. A acceleration, v final, u initial speed over time. We know the acceleration is 2.67 approximately. We don't know the final speed, that's what we're trying to find. What's the initial speed? It's 0 because it says the cat's at rest. So the cat's not running away yet, or it's probably too late for kitty cat. So if we rearrange this, bring the 3 over, 8 meters per second. So if the cat was sitting on a table 2 meters wide, will it fall off? What's the equation for distance or displacement? The displacement equals the initial speed times time plus half times the acceleration times the time squared. Again, you can use calculus to find this. So this is 0 because the initial speed's 0. We know the acceleration and we know time. So we found. Anyway, we definitely know, if you just look at this basically, it's definitely going to leave the 2 meter wide table. Assuming it's in the middle of the table, it's going to be more than 1 meter. Let's look at momentum. Momentum, some of you may not have done in physics. I don't know, maybe you have. So momentum, for whatever reason, I actually don't know, they use the letter P for momentum. Momentum is the mass of an object times its speed or its velocity. My fat cat, 7.5 kilograms. So it's momentum. What's the units for momentum? Kilograms, meters per second, or newtons seconds.